Hello students, welcome back to our discussion of Chapter 2. So we had just finished, in the first video, we had just finished calculating the average weekly wages based on this grouped set of data. I'm going to go back to slide 6. The last question here is why calculate the mean of grouped data and not the mean of the ungrouped or raw data instead? Well, sometimes you don't have the actual data. You don't have the raw data or the ungrouped data. You may only have data presented to you in this format. So we don't know exactly where, for example, in the first class, we don't know exactly where or how much the 24 employees earned. We know that 24 earned between that range, but they could all be, close to 360 or 400, or they could be right around that average midpoint value of 380. So because we don't have the actual raw data, we have to create that estimate of the average for the weekly earnings. So let's just continue our discussion. The second type of measure of centrality, it's the median. Median is simply the middle value when data is placed in ascending order. Smallest to largest, unless of course you are using Excel. So you can always check your answers using Excel. The function in Excel is equals median, bracket, highlight the data, close your bracket. If there's an odd number of values, the median is the middle value. If there are an even number of values, you're going to have two middle values. So then the median becomes the average of those two middle numbers. So let's look at an example. We have data set 1. These are on page 28 of the course package, and data set 2. So I'm going to go into Excel where I have those two data sets up here. Let's just give me some more room here. So we have these two data sets, 3, 4, 4, 8, 10, 11, 15, and 7. We already calculated the average. The average was 9, but let's calculate the median. Actually, before that, the median value is there's 8 values in total. Highlighting all the values, we can find that there's 8 in total. So basically, there's our two middle values. So the average between 8 and 10 would also be 9. So the median would be 9, and we can verify that by using this Excel function. Median, bracket, highlight all the values. We get a value of 9. There's our median. There's our mean from earlier. Let's make that nice and centered. Okay. In data set 2, the values are not placed in order. So that's the first thing we need to change, is to place, especially when we're doing this on paper. So we have a value of 2. We have 2 3s, and then a 4, 5, 6, 7, and 2 8s. Oops. I'm going to center that because that's what I do. The sum, I'm just going to make sure that I have everything. The sum of those 9 values is 46 down here, and the sum of the rearranged values is also 46, so it looks like I did this correct. So the median is going to be, there's 9 values. The median is going to be right there. There's our middle value. Let's make that red and bold. There's our median, and we can verify that by doing that Excel function. Median of this is 5, and just to show you how smart Excel is, we can also do the median of the values not placed in any order, and the median of those 9 values is 5. So once again, the median is simply the middle value. If there's an even number of values in your data set, there's going to be 2 middle values. We take the average of those 2. The mode is basically the observation that occurs most often. it can be bimodal where there's two modes. It can be multimodal where there's more than one modes. The Excel function is mode equals mode bracket, highlight all your data. As I said there, the caution is that Excel will only find one mode, even if there are two or more modes. So it'll only list the first mode it comes across. There are ways to find the subsequent modes, but that's something that generally is not as needed. So let's look at an example. We can go back to our first and second data sets. We can type in mode there. Mode is 4, and that's what we would list. We don't list that it occurs twice. We just list the value that does occur twice. And we can use this in Excel. Mode, bracket, highlight all your data. There's mode of 4. In the second data set, it looks like there's going to be two modes. Right? We have a value of 3. We can tell it here when we've listed it in order. A value of 3 and a value of 8. So it's bimodal. We would list both. Excel is going to list, using that function, is going to list the first one in both cases. Yeah, if we ever need to find the other modes, there is an Excel function that we can use, but in most cases that is sufficient. So the other type of measure of centrality is something that's called how skewed the data is. We can look at the skewness of it. It's basically, in the simple terms for what we need in this course, is just the difference between the mean and median. It does tell us that the data is evenly distributed or how distributed the data is. We calculate this because the mean is often influenced by extreme values called outliers in statistics. So we can look at an example of calculating mean or calculating the skewness. We have data set 1 where we have the mean is of 9 and the median of 9. So the skewness of this value is going to be is mean minus median. So if that value of 0 tells us the data is perfectly symmetrical. There's same number of data on the lower end and same number of data on the upper end. Now let's calculate the average of the second data set. The average is 5.11. So the skewness of this is going to be the average minus the median. And it gives us a value of positive 0.011. So that basically tells us that the data is positively skewed. There's more data on the upper end of our data of the data set. It's skewed to the right. We'll go into that in more detail in a moment. Let's look back at our PowerPoint. There's an example here. When we include LeBron James, we can talk about the mean and median income of students in the classroom. Generally, if a classroom is a typical college student, the average income and the median income are going to be the same. Now, if LeBron James were to join a class, and I just Googled how much money he earns, and it's like close to $37 million. And if he were to join a class, we would calculate the average, $37 million plus whatever we're earning as, or whatever you're earning as students. Divide that by, say there's, for simplicity, 37 million or 37 students in the classroom, then that would indicate that the average income in the class is $1 million. On average, every student in this class is earning $1 million. Really misleading. If we were to calculate the median income, if one more student were to join the class, like LeBron James, the median income is going to move up half a position, really. So the median income is still going to be going to be the best measure of centrality in this example. The mean is often influenced by extreme values, like LeBron James coming in class. The mean would not be a good indicator of the actual measure of centrality for this classroom. We can look at, here's some points about how skewed the data is. Just keep in mind that Excel will calculate how skewed the data is different. We are only looking to see, first point here is if it's positive or negative. We're keeping this really basic. We just want to know if the data is skewed negatively or positively. So positive, if mean is greater than the median, it's skewed to the right. Generally, that means that there's some higher values that are pulling the mean upwards. Negatively skewed, there's more low values pulling the mean or pulling the average down. So let's go into a couple examples we can do to help us understand this. Examples are on page 28, or 29, I should say. So there's the values here, 4, 6, 8, and 10. We're going to calculate the average. So let's put this in here. The mean, can't type. The mean and the median, and then what the skewness of that data is. So the average, using that average function, of course, pen and paper, add those 4 values up, divide by 4, gives us an average of 7. The median, those values are in ascending order. You should be able to readily indicate that the median is going to be the average between 6 and 8, which would also be 7. We can calculate the average and the mean for the second data set, and we get the median is still 7. Yep. So in the first case, mean minus median gives us how skewed that data is. Basically a value of 0 indicating that it's symmetrical. In this case here, it is positively skewed. We're not concerned about the absolute cell or number there. We're just concerned if it's positive or negative. So basically it's positively skewed, which means that there's at least one value pulling the average upwards, and we can readily see this value of 10,000. It's an outlier. It's pulling the average up higher, but the median does not change. So that's our really basic purpose and use of measuring the skewness or the symmetry of the data set. So the next video for this chapter, we'll talk about measures of variability.